Hello everyone, welcome back. In our previous video, we laid the groundwork by exploring the broad classification of variables, qualitative and quantitative, based on whether the variable is expressed numerically or not. That gives us a solid foundation for understanding how variables differ in structure and meaning. Now, we are taking that understanding a step further. In this video, we will explore a more refined classification system, one that goes beyond the presence of numbers. We will look at how variables differ based on the three essential characteristics: order, measurable distance, and the existence of a true zero point. Understanding these scales is essential because they determine what kind of statistical analysis and visualizations are appropriate. Let us break them down with examples and key properties and analytical implications. Stay with me. Nominal scale is under qualitative variable, where the values associated with nominal scale useful for labeling or naming, right? Without any ordering, no mathematical operation, no meaningful distance, or zero issue. For example, gender, nationality, eye color, these all are nothing but examples of nominal scale. For example, if we consider gender, what are the possible values of gender? The common values are male or female. This male and female serve only for labeling. We can't say that male is greater than female or female is greater than male. We don't have any ground to say so, right? What the appropriate statistical tests or methods with such scale is nothing but testing for association of two variables, where the two variables are nominal scale. For example, whether one variable has an effect over the other variable, we can test using chi-square test, right? This test is known as association test or independency test. Fisher's exact test for small samples, MC-Neymar's test for paired nominal, and we may make use of logistic regression for binary. Binary is nothing but dichotomies, right? On, off, success, failure, yes, no, this, live, these all are binary. To model such binary variables, we can use logistic regression. This is most applicable in supervised machine learning. And the common presentation types for nominal scale include bar chart, pie chart, frequency tables. So let us proceed to the ordinal scale. Ordinal scale includes all the properties of the nominal scale, but this ordinal scale adds extra property, meaning the possible values of ordinal scale have meaningful order, right? The possible values of a given ordinal scale can be compared meaningfully. But the limitation here is there is no exact distance in between the values, right? For example, educational level may take on possible values: high school completed, BSc, MSc, or PhD. But we don't know the exact distance between PhD and master. Exactly. This is a limitation with ordinal, right? Socioeconomic status, the same is true: middle income, high income, low income. So meaningful ordering is possible with such scale, but the distance is not known. What the appropriate statistical tests can be performed with ordinal scales include, most of these are non-parametric tests, except the ordinal regression, right? Mann-Whitney, Wilcoxon, Kruskal-Wallis, Spearman, Rowe, Kendall's, Tau, these all are non-parametric. For testing two groups paired, for more than two groups, for correlation, rank correlation, and or for modeling. For modeling, instead of logistic, now we make use of ordinal regression in ordinal scale. What the appropriate presentation types for ordinal scale include bar chart, stacked bar chart, median or rank plots, right? What the third scale is nothing but interval. This interval is quantitative, right? Numerical by nature, right? So this came from quantitative variables, right? So this interval scale includes all the properties of the ordinary scale too. But here, this scale adds one extra property. There is equal and known distance in between values, right? Unlike that of ordinal, now the distance is known. But what the limitation here is not true 0 point, right? 0 is arbitrary. Example of such interval scale include temperature in degrees centigrade, IQ scores, shoe size, calendar, and etc. Here the 0 does not imply the complete absence of the quantity. For example, 0 degrees centigrade, it doesn't mean that there is no hotness, right? If someone is examined for intellectual quotient scores out of 100, and if he scored, unfortunately, 0, that 0 doesn't mean that he knows nothing. So that 0 is not real 0, unless it is arbitrary. What are the common or appropriate statistical tests or methods that we can perform with interval scale? We can perform t-test for comparison of means for two groups, ANOVA for more than two groups, Pearson correlation for computing correlation coefficient of two quantitative variables, linear regression. Now, linear regression is applicable for interval scale and ratio scale, not applicable for ordinal scale, even for nominal scale. What are the appropriate presentation types now for interval scale? For interval scale, we can make use of presentation types such as histogram, line graph, box plot, scatter plot. Now, the last but not least is the ratio scale, which is highest scale. Right? This is the highest scale, whereas nominal is the lowest scale, based on the enrichedness of the properties. Right? This ratio scale includes all the properties of the interval scale, but it adds one extra property. With ratio scale, there is true 0 point that allows all mathematical operations meaningfully. Right? Now, here the 0 implies the complete absence of the quantity. Right? If there is no coin in my pocket, that is the true 0. I don't have any coin in my pocket, refers the quantity is 0. Right? So, variables that regarding as a ratio includes height, weight, income, reaction time. Right? These are ratio scale. The statistical tests or methods and presentation types are the same with that of interval scale. Now, what's the difference between ratio and interval scale is on the application of ratio quantity. Ratio meaning division and multiplication has no meaning with interval scale, but with ratio scale, this addition, multiplication, division, subtraction, all these mathematical operations are meaningful, right? This is due to the presence of true 0 point. From mathematical rule of thumb, if there is no fixed 0 or true 0, it is not possible to perform multiplication and division. These two mathematical operations calls for having fixed 0. So, with interval scale, we can perform only addition and subtraction meaningfully, right? So at the same time, from this we can understand that we cannot perform ratio meaningfully with this interval scale. This is the difference between ratio and interval. So measurement scale in SPSS, for example, let us consider, right? This screen sheet or window is a variable view window in SPSS, which manages the variables. So these four variables have their respective measure values under the measure column. For example, variable 1 takes value on unknown. This is a default value if we didn't specify one of these measures of scale. Otherwise, for example, gender is nominal. From this drop-down menu, we select as this gender variable is nominal. This monthly income is a scale, right? Monthly income such as 2,000, 3,000, 4,000, 1,000. This is quantitative, right? And it can be classified as a scale measures of scale. Statistical software, which is SPSS, considers both interval and ratio as one, which is named scale, provided that the difference into consideration. While the education level is a variable which is classified as ordinal. If you have found this helpful, subscribe and stay ahead with me. Thank you.